Welcome to TOC class. So in this class I am going to explain the problem of conversion of PDA to CFG. So here P is equal to some values are available. So consider first step is given value. So given value means P is equal to 7 tuple representation, that means Q sigma tau tilde your starting state, stack symbol, then final state. So these are all the 7 parameters. So first we should take Q value, that means the first input value. So Q is equal to P comma Q, and sigma is the second parameter of push on automata, that is 0 1, and third parameter value is your stack symbols. So the stack contains only two symbols in it. Either it can store X value or Z0. Then Q is the starting state. So I am writing it as starting state is equal to Q, and initial stack symbol. Initial stack symbol is Z0, and we should write final state. Here final state is not given. Later we can able to construct the final state notation. Okay. Then we should write possible productions, because the problem is conversion of push on automata to context free grammar. So every context free grammar should contain a production in it. So I am taking S as a starting symbol of the given grammar. So this can be created with 3 parameters. So the first parameter is your starting state. Here the starting state is Q. And the second parameter is the initial stack symbol. So that is Z0. Third parameter is your capital Q value. So either P, otherwise Q can be used. So there is a possibility of writing two different starting productions. Either you can retrieve the productions from the first one, otherwise you can able to construct it from the second one. Then we should write the possible variables. So how can we write possible variables? Means V is written with the combination of set of states and set of stack symbols. So this will be already written here. So the set of states are P and Q, and set of stack symbols are X and Z0. So I am writing possible variables. My starting symbol is S, and you should write square bracket. In the square bracket, the first and third parameters are states. Second parameter is only the stack symbol. So how many states are there? 2. So what are all the variables can be written? Means 2 power 2, 4 parameters can be written. So I am writing 4 parameters here with the 2 states. So the states may be PP, or the states may be PQ, or it may be QP, or it may be QQ combination. Then the mid value should be written with alphabet notations. That means the stack symbol notation. There are 2 stack symbols are available. First I fill the first stack symbol. Okay. Otherwise the same combinations, either PP or PQ or QP or QQ combinations. The mid value is Z here. So this is possible variables. It's not necessary to retrieve all these 8 variables from this 6 different functions. Okay, this is only assumption. So these are all comes under step 1. Okay, then step 2. In step 2, we should write the first transition function. So I write the first transition function. It is nothing but tilde of Q1 Z0 is equal to Q comma X0. Okay. Then you put the number here 1, 2, 3, 4, 5, 6. So how can you write it? 1, 3, 4. This is a variable implies 2 and 2 different variables with 5 value and 6 value here. Then this fourth value should be written here and this fourth value should be written here. And these two values are same, that is written from Q. So I am writing the notation that is nothing but Q Z0, Q implies the second value is 1, the fifth value is X and the sixth value is Z0. And here I should write the fourth value, that is Q. And this last value is from this one. So this is also Q. These left and right side values are Q. So Q is retrieved from step 1. That is either it may be PP or it may be QQ combinations. The remaining notations are same. So I write the remaining notations as it is for this function. And you just check the state. The state is Q. So I am writing two different productions for Q. P is also available in capital Q. So if you want to write the productions for capital Q with P symbol, only the third parameter is changed. So I am writing the third parameter as it is. So instead of Q, I am writing P. So if this value is changed, the last parameter value only changed. So the remaining are same. So I am writing the remaining letters as it is. And the last parameter is P. This will be the left side value. So I am writing it as it is. So these two values are same. If it is P, this is also P. If this is Q, this is also Q. So for a single transition function, I can able to retrieve 4 different productions. Then you should take the second notation. That means Q0x equal to Px. So I am writing the second notation Q0x equal to Px. Okay. So you put the number 1, 2, 3, 4, 5. So you can write it as 1, 3, 4 implies 2, 5. The fifth value is X. And this notation is, this P is filled here and this P will be written here. So only one production. So you check that value, it is P. So you write it as for P. And for Q, only the third value is changed. So QXQ implies 0, PX, this value is that one, so Q. So this is the second production notation. Then take the third one, P1X equal to P epsilon. So P1X equal to P epsilon. So this comes under type 3. So this is type 1. Second transition function is like type 2. Third transition function is like type 3 format. So I write directly 1, 3, 4 implies 2, 5. 5 is epsilon. So I am writing as it is. Okay. Then you check the next one. Q1x equal to Qxx. So this is the fourth function. Q1x is equal to Q comma xx. So this is 1, 2, 3, 4, 5, 6 value. So there is a possibility of 2 productions. If any 2 value is there, 2 productions are necessary. So 1, 3, 4 implies 2. Fifth value is x. Sixth value is also x. And this fourth value is filled here, that is q. And this q value should be written here. If it is p, this is p. If it is q, this is q. The remaining notations are same. So write the remaining symbols in a production as it is. This is for Q. So just check Q. So this is for the state Q. And for P only the input third parameter value only changed, that is QXP. The remaining notations are same. So I write those values as it is with P. So this is, if it is Q, this is also Q. And this P will be written at last side. Okay, this is the fourth function. And check the fifth function, Q epsilon Z0 equal to Q epsilon. So Q epsilon Z0 equal to Q epsilon. It's like type 4. So type 4 is simple. Q0 Z0 Q implies epsilon. Then go to the sixth format, that is P0 Z0 equal to Q Z0. So P0 Z0 is equal to Q Z0. So it contains one variable, so only one production is possible. 1, 3, 4 implies 2, 5. Fifth mid value is Z0. This should be written here. And if it is Q, this is Q. So the third value is Q. So this is for Q state. For P state, the answer is P Z0 P implies 0 Q Z0 P. So this is step 2. Okay, thank you.